Hello class, this is the video for section 4.4, the graph of irrational functions. And here our learning objectives are two, but we'll only do the first one, that is graphing a rational function. Okay, so let's take an example. Say graph a rational function with a hole in it. Okay, we talked about this in data 4.3. And so we're going to take example. Here is a rational function. Its f of x is equal to x squared minus 4 divided by x plus 2. Okay, so first thing is that it said there are 7 steps that we go through. Step 1, we have to what? Factor this expression. Okay, so let me change my color. So we have to find a factor f of x, which is what? X squared minus 4 over what? X plus 2. So what happened is that you have x, the numerator is a difference of squares. So that's x plus 2, and then x minus 2 divided by what? X plus what? X plus 2. Now, what is the domain? What's the domain? Domain is what? All real numbers, okay, such that x is not equal to minus 2. That is when you set the denominator what? To 0. Okay, so, but this can be simplified into, if step 2 says that write r or write a function in the lowest terms, write a rational function in lowest terms. Okay, so we have this function that we have right now, f of x, okay, which is x plus 2, x minus 2 divided by x plus what? S plus 2. Now we notice that this factor will cancel out. So the f of x, the rational function now is what? X minus 2. Okay, so let's write a f of x here. In the lowest terms is equal to what? X minus 2. So when you have this, because this factor, the factor x plus 2, there is a hole, okay, in the graph at x is equal to what? Negative 2. Okay, so let's go to step 3. Now step 3 said find and interpret what? The intercepts of the graph. Well, now our f of x, or the rational function, is just what? X minus 2. So what is the x-intercept? For x-intercept, we have f of x is set to 0. Okay, so let's have x-intercept first. Okay, that is f of x equal to 0. So you have what? X minus 2 equal to 0, and then x is equal to what? X is equal to 2. So you have 0, what? 0, sorry. You have 2, 0. And then the y-intercept, you have what? You set x to 0, which meaning f of 0 is equal to 0 minus 2, which is what? Negative 2. So the y-intercept is what? 0, negative 2. Okay, and it says that use multiplicity to determine the behavior of the what? Or the graph in this. Well, in this factor, this is a line. Okay, so the behavior of what do you call it? is a use of multiplicity to determine the behavior of the graph of the rational function at what? Each x-intercept. Well, the x-intercept, what is the behavior at this point? Okay, what's the behavior at this point? Well, the x-intercept has what? This is just 1. It has a multiplicity of 1. Okay, so at the x-intercept, the multiplicity at x-intercept at x is equal to what? 2. It has a multiplicity of what? 1. So it means that graph what? Graph crosses, it crosses what? X-axis. Graph crosses X-axis at that point. Okay. All right. Now let's go to step 4. Is to find the vertical asymptotes and graph each vertical asymptote using a dashed line. Okay. Determine the behavior of the graph on either side of each vertical asymptote. Well, according to this function, when we simplified it, we have just x minus 2. Okay, so there's no function, there's no value of x such that the denominator is what, 0. The denominator is 1. Okay, so this one has what? The function has no vertical what? Asymptote. Okay, it has no vertical asymptote. In fact, it is a line. Okay, the equation is a line. All right. Then let's go to step 5. It says find the horizontal asymptote or an oblique asymptote. Okay, and then grab the asymptote using a dashed line. Find points, if any, where the graph of the rational function intersects what the asymptote, whether it is what, horizontal or vertical. Okay, so here again, our function is what, x minus 2. Okay, any horizontal asymptote. Okay, any horizontal asymptote. Well, it has no horizontal asymptote, it's just a line. Okay, this one has no horizontal asymptote. Horizontal asymptote or oblique what? Asymptote. Oblique asymptote. Okay. All right. So now let us see how we can graph this. Step 6. It says plot few points. All right. I have what? At least I can have the f of x is x minus 2, and there's a hole at x is equal to -4, -2. So this is x. This is my f of x. If x is 0, this is -2. If x is y is 0, this is 1. This is 2. Because we have these points, so we can draw the graph, okay, and then put a hole at what x, where x is equal to -2. So step 7, we're going to put all this together and then graph what? The function. All right. Well, we have f of x is what? X minus 2. And there's a hole at what? X is equal to -2. We have the x and y intercepts. So if you draw a line, okay, we have x and y intercepts. Okay, this is 1 and 2, and then 1 and -2. Okay, the function crosses the x-axis, okay, at the intercepts, and then we have what? 1 and then -2. Okay, -1 and -2. So when x is equal to -2, all right, because we have to get that point. So let's put the points here that we got in the previous. We have x and the f of x. This is 0. This is -2. This is 0. This is 2. Now, if x is what, -2, I get what, -4. But there's a hole at that point. So if this is 2, and then we have 4, this is 3 and 4. Okay. If this line, let's draw the line passing through x-axis. Let me erase the line. I pick my pen again. So we have, it passes through this, okay, and then comes down to that. Okay, so let's say that this is where they intersect, and there's a hole there, and so you have it's gonna put it better way up. Yeah, let's have our line vertical axis. Okay, let's call this is a -4, -3 and 2. So there's a hole in the what? This is my x and y axis, x-axis, and that's the line. This is a f of x is equal to x minus what? X minus 2. Okay, there's a hole at x is equal to -2. All right. So this brings us to the first example. Let's go to the second. Okay. The graph the rational function f of x is equal to x squared minus 3x minus 4 divided by 2x squared plus what 4x. Note that we use this example in section 4.3. Okay, we found the intercepts, we found the vertical asymptotes, the horizontal asymptotes, and where it crosses the horizontal asymptote, or if you had the what do you call it? If you had the oblique where it crosses it. We have done this, but I'm going to repeat it so that we can put all information together and graph this this function. So factor the numerator and denominator of the what? The rational function, and then find the domain. Well, so we have f of x, okay, which is x squared minus 3x minus 4 divided by 2x squared plus what? 4x. Now, if I factor, okay, we have x minus 4 and the x plus 2 divided by 2x and the x plus what? So x plus 1 and then, okay, x plus 1. This is in the factored form. So what's the domain? Domain is what? All real numbers, okay, such that x is not equal to 0 and then what? -2 or -2 and 0, okay? Now, this is the factored form. That my f of x is what? If in the reduced terms, is the same thing, minus 4, x plus 1, and then 2x, x plus what? X plus 2. Okay, so we have the domain. We have what? Steps 1 and 2. Okay, remember we've done this before, so it's easy to remember that. Okay, so now find and plot the intercepts of the graph. Okay, use multiplicity to determine the behavior of the graph of the rational function at each what? X-intercept. Okay, so what we have here is that let's find y-intercept first. Y-intercept. We said this what? X is equal to 0. Sorry, that's not, I quickly wrote that down. Okay, so we want to find when this is what? When x is equal to 0. But we know that as a function here sits here, okay, s cannot equal to what? Equal to 0. And therefore, there is no what? No y-intercept. No y-intercept. Okay, now what is the x-intercept, or what are the x-intercepts? Okay, here is where we set the function to what? To 0. So we have what? X minus 4, x plus 1, divided by 2x, x plus 2, equal to 0. So here we set the numerator, just the numerator, because if you cross multiply, the 2x times x plus 2 will multiply by 0, and that goes to 0. So you have x minus 4, x plus 1 equal to 0. And that gives us s is equal to -1 and 4. So the x-intercepts are what? What do you call it? -1 and what? -4. Now each, okay, each x-intercept, each x-intercept has a multiplicity of what? Of 1. So a graph crosses the x-axis at what? At the x-intercepts. Now notice that the x-intercepts are what? Are the zeros of the function. Okay, it crosses there. Good. Now let's go to step 4. It says find the vertical asymptote. All right, and then determine the behavior, basically. The vertical asymptote And then at each, determine what the behavior of the graph at each side of it. Okay. So the first, what do we do? What are the vertical asymptotes? Let's write them here. Vertical asymptotes. What are they? Okay, the vertical asymptotes are the values of x for which this function is undefined. In other words, the zero, the denominator is what, zero. So these are the lines, x is equal to 0 and x is equal to what, -2. Okay, x is equal to 0, x is equal to what, -2. Now we're going to show as x approaches each of these, what's the behavior of the what, f of x. Okay, now what we're going to do is this. I'm going to write this down. Okay, I want you to note something. Okay, I'm going to draw a table, but I want you to note something here. Let me draw the table first. Okay, so we're going to have a table. Okay, and we will go write this as x. Okay, when I write this, it means that x approaches. Okay, I'll write a note it down here. X approaches. We have -2 to the right, so -2 from the right. We have the -2 from the left. We have 0 from the right. And then what? 0 from the left. Okay. So what we do is that we pick a test value. A test value of x. And then we find the test value of x. And then what is the y value? In other words, what is f of x? F of x equals what? Using that function there. And then what's our conclusion? Okay. Remember your y is the same as the x. So we say that so y approaches what? Or we can say f of x. Now note that, okay, when I write this x, this, okay, say minus, what does it mean? This means x approaches -2 from the right. And then if you write x -2 left, it means x approaches what? -2 from the left. Okay, so let's pick a test value. If you have this line, okay, you have -2 and they have 0. Now, and just any value to the left of this, but very close to it. Okay, you can pick as a negative, something very close to like a negative for 2.1. Okay, or I can use even -3, for example. All right, so if I use -3, okay, and then on this side, if to the right, if I use what, say -1, because to the right of that, and then 0, from approaching it from the right, I can use 1, and this one too, I can use like 0 point, maybe -0 point what, 0.1. Okay, something very close to that. Now, what is this value? That means I plug this value into what, this function. I just want the sign. I don't want the value. Okay, what's the sign of the value? Okay, so you have what, x, -3 minus 4 is negative. Okay, -3 plus 1 is also negative. And then 2 times negative is negative there. And then -3 plus 2 is what? Is also is negative. Let's see. So you have negative, negative, and then negative and positive. Okay, let me change something here. Let's change that. We got to pick the values very close to it. Otherwise, sometimes it won't give us the right answers to that. Because I've done it before and I know something is not right. Okay, so here we're going to pick like negative, okay, from the right. So we can put like 1.9, a value like that. And then from the left, we can use one negative 2.1. And then here we can use 0.1, and then here negative 0.1. Okay, to the right and left of 0, and then, okay. So if you have negative 1.9, this is negative, that is going to be also negative, and you have negative, and this will be positive. And so if you have this will just be positive over what? Over negative. So that goes to what? Negative what? Negative infinity. Okay. And then when you have negative 2.1, plug it into this same expression. Okay. You have what? It's negative for that. And then negative 2.1 plus 1 is also negative. Okay. And then we have what? 2 times negative, which is negative. And then negative 2 plus negative 2.1 plus 2 will also be what? Negative. So this could be what? This will be positive. So this goes to what? A positive infinity. And then when you plug in 0.1 into that, okay, this is negative, the numerator, and then 0.1 plus 1 is positive. Okay, 2 times the positive value will be positive. And then 0.1 plus 2 is also positive. So this is what? This is negative what? Infinity. And then finally, negative 0.1 into that. Well, the numerator, the same thing, is negative. This will be positive. And then you have what? Negative times positive. So that goes to positive what? It's positive infinity. Okay. So that means that if I have the graph like this, we'll draw in the graph very soon. I have what? The vertical asymptote. This is what? This is a vertical asymptote. S is equal to 0. Okay. S equal to 0 is a vertical asymptote. And then we have what? Negative 2. Okay. So what is happening is that if I approach it to a negative 2 from the right, okay, if I approach it from the right, it goes to negative infinity. So it goes like that. And then approaching from the left, it goes to what? Like that. And then approaching 0 from the right, we got what? A negative infinity. From the right, we got negative what? Infinity. Did I get that right? Approaching from the right, you get negative infinity. And then approaching from the left, you get a positive what? Positive infinity. Okay. All right. So that is what is happening. All right. So we got this. Now let us go to the next step. Step 5. Okay. Horizontal asymptote, and then what I have is horizontal or an oblique asymptote. Well, what's the degree? If you look at the degree of the numerator from the original function, all right, we had what was x squared minus was 3x minus 4, all right, divided by 2x squared plus 4x. Okay, so the degree of the numerator, okay, the numerator n is what? 2, and then the degree of the denominator m is also 2. So it means that we have, here's a case, you have what? Your n is equal to m. And so the line, okay, y is equal to the leading coefficients, which is 1 over 2, is what? Your horizontal what? Asymptote. Now, a function, a rational function cannot have both horizontal and oblique. Okay. So now we want to determine whether it crosses it. Okay, we did this, so I want to repeat. Now, to show that, okay, does the graph cross the horizontal what? Asymptote? That's the question. So we solve the equation. We have f of x. We set it to the y equal to 1.5. Okay, and solve that. So then we have what? X minus 4 times x plus 1 divided by 2x, x plus 2 equal to 1/2. So when we cross multiply, that's 2 times this. So it'll be 2 times x minus 4, x plus 1 is equal to 1 times what? 2x, x plus what? Plus 2. Okay, so let's multiply this out. You have 2, that'll be x squared, okay, minus 3x minus 4, all right, equal to what? 2x times x plus what? X plus 2. So if you multiply this, you have 2x squared minus 6x minus 8 is equal to 2x squared plus what? 4x. Now, if you subtract 2x, this will cancel out. And so you have 4 minus 6x minus 8 is equal to what? 4x. Okay. And then if you bring the subtract minus 4x from both sides, okay, that gives us minus 10x is minus 8 equal to 0, and minus 10x is equal to 8, and therefore x is equal to minus 8 over 10, which is what? Minus 0.8. Okay, so what does it mean? Okay, what does it mean? It means that the graph, okay, we want to say that the graph crosses the, because that's what the question, does graph cross the horizontal asymptote? So the answer to that is what? Yes. Okay, at what point? Minus 0.8 and then what? And 1/2. Okay, so now let's go to this last but one step. Okay, plot few points. Okay, here we look at the zeros of the numerator. Zeros of the numerator, if you set each of the factors to 0, you have what? We get minus 1 and 4. And then we have the zeros of the denominator. Okay, and that also is what? Will be 0 and then what? Negative 2. So at this point, I'm going to what? Plot a few points there. Okay, I'm going to pick a few values near each of them to the side. So this divide, okay, you have some intervals here. Okay, you have minus 2, you got negative 1, we have what? 0, and we have 4. Okay, so at each interval, I'm going to have what? Say minus infinity to negative 2, minus 2 to negative 1, and then we have what? Minus 1 to 0, and 1 to what? 1 to 0 to 4. Okay, and then we have what? 4 to what? Positive infinity. So I'm going to pick values of x in each interval and then what? Evaluate. Okay, so this is my f of x. Okay, so when I look at it, in this interval, I'll pick what? Negative 3 for the first one. The second one, I'm going to use negative 1.5. Sorry, negative 1.5. The next one, I'm going to use just negative 0.5. Okay. And then the next one, I will just use 1. And then next, I will use what? I'll use 5. Then when I plug it into the function and evaluate, these are the answers I get. Okay. I get 7 over 8. And let me turn on this light. So if you plug negative 3 into the function here, you have for 7 over 3, not 8. Okay, 7 over 3. And then when x is negative 1.5, I got negative 11 over what? Over 6. And then when it is what? Negative 0.5, I got 3, positive 3.5, and 1, I got -1, and then 5, I got 3 over what? 35, which is approximately 0.09. Okay, so we have all this together. We want to put it and then graph what? This the function. Okay, so let us put it together. All right, so here is our X and Y plane. Okay, X and Y plane. Now we know our what? Our intercepts. Okay, this is 1, this is 2, 4, and 5. Okay, this is my X, Y axis. That's my X axis. All right. So we have our vertical asymptotes. Okay, the vertical asymptotes are the Y axis. Okay, so this is if I use a different color. All right, to use a dashed line. Okay, this is what? This is a vertical asymptote, and the line x is equal to 0. And then we also have at what? -1, -2. Okay, -2. We have this. Okay, that is also x is equal to -2. All right. Now, what are the intercepts? Okay, -1. X intercepts are -1 and what? -1 and then 4. Okay, it has no y-intercept. Okay, it has no y-intercept. Now let me change the color. It has no y-intercept. Now we know that as x approaches -2 from the right, this goes to what? It goes to -infinity. Okay, so it goes to -infinity like that. Now as approaches what? -2 from the left, it goes to what? Positive infinity. All right. And then as x approaches 0, vertical asymptote 0 from the left, that goes to also positive infinity. Okay. And then as x approaches 0 from the right, that goes to what? A negative what? Infinity, like that. Okay. Now, these are the other points. You got -3. All right. -3 is what? 7. If this is 1, this is 1. Okay. What is our horizontal asymptote? Okay. If I call this 1, my horizontal asymptote is what? Is the line y is equal to half. Okay. So this line is your equation 1.5. That's your horizontal asymptote. Okay. So does it cross? Does it cross the horizontal asymptote? Yes, it crosses at what? Negative what? At negative, if x is negative to 0.8, so it crosses that what? At this point. Okay. And then if you have -3, -3 is +7, which is let's say 2 point something. All right. So that is somewhere here. And then if you x is what? -1.5, it goes to -11 point, what is also about 1 point something. So if this is half, this is 1. Okay, that is somewhere there. And then you have what? -0.5, it is 3.5. Okay, 3.5 is what? 1.5, which is there. Okay, which is half of that. Okay, and then if it's 1, +1 is -1. Okay, 1 is what? -1, which is here, because that's half. And then have 5 is point. That is somewhere. If it is 5, it is something like very, very small, somewhere there. So you could see that the graph is what? It never touches the horizontal, but it goes to this point. Okay. And then we have that side. Okay. then it's what? It's from goes to infinity, crosses that, and goes up like that. Okay. And then it passes to this point, and this point is, this is what it goes to, all right, and then comes down closer like that. Okay, so it has all the properties we have. It has the vertical asymptotes, the horizontal asymptotes. It crosses what? The horizontal asymptote as x is equal to negative 0.8, which is at y coordinate is what? 1/2. So like that. So that gives me this what? This graph for this function. Okay, very good. Now let's look at the next example. That is graphing this function. R of s is equal to s squared minus what? Minus 4. So we go to the similar what steps. So step 1, we say we factor. So the numerator is what? Difference of what? 2 squares. So that's why we have x plus 2 times x minus 2 divided by what? Divided by x. Okay. So what's the domain? Is everything except x is equal to what? 0. Okay. Then step 2, it reduces in the lowest term. Okay. It is in this what? It is in this lowest term. So the r of x in this case is the same as x plus what? 2 x minus 2 divided by what? Divided by x. That's its lowest terms. It could be. All right. Now we have to find the x and y intercept. Because x cannot equal to 0, okay, the graph has no what? Has no y-intercept. Similar to the previous example. Okay, what are the x-intercepts? All right, you take the what? X plus 2, x minus 2 over x and set it to 0. And then it means that you set the numerator, which is x plus 2 times x minus 2 equal to 0. So you have what? X is equal to plus 2 and then minus 2. Okay? All right. Now let's go to step 4. The vertical asymptote. Okay, the vertical asymptote for this function. All right. What's the vertical asymptote? All right. So you have for f r of x, which is x plus 2, x minus 2 divided by what? X. So the vertical asymptote is the line. Okay. Is the line x is equal to what? 0. All right. So if we are approaching the 0 from the left and right, what happens to the graph? Okay, so this is where we draw what? A table. Okay, and we say that as x approaches what? 0 from the right, and then 0 from the left, and then we have what? Test value. Okay, and then this is our r. That's the sine of r of x. Okay, I just want the sine of it. Okay, so sine of what? R of x. Okay, and then so what's your conclusion? As so say you say that what? The f of x, so in this case is your y. Okay, y approaches what? Y goes to what? Okay, so again, if I use a very small value like 0.1, okay, the numerator, that 0.1 plus 2 is what? Positive. Okay, and then okay, it is positive. And then 0.1 minus 2 is what? Negative. And 0.1 is positive. So the denominator is positive. So this gives me, it goes to what? Negative infinity. In fact, it gets smaller, but negatively. And then if I use negative 0. Let's say 0.1 when it's approaching it from the left, all right? Okay, what do you have? Again, if this is negative, this will be positive still. That got negative 0.1 plus 2, that's positive. And this will be negative as well. And then the denominator will be negative. So this goes to what? Positive what? Infinity. Okay, so this is your vertical what? Asymptote. That's a y-axis. As you're approaching it from the left, okay, from the left, it goes to positive infinity. It goes like this. And then approaching from, what do you call it? From the left is the other way. It goes like this. And then from the right, it goes what? It goes like that. Okay. So let us make sure let's erase this part. All right. Now let's go to the next step. We find a vertical, let's find a horizontal asymptote. All right. Now, what is our function? Okay. Now remember, our function originally is what? It is r of x is equal to x squared minus 4 divided by x. Now you notice that your n is greater than what? M by what? By 1. So this will have what? An oblique what? Asymptote. Okay. It will have an oblique what? Asymptote. Now, if you have oblique asymptote, that means we have to what? Use the long division to divide this. So it means x is going to divide x squared. We got to introduce the missing term, which is what? 0x, then minus what? 4. So x goes into x squared is what? X. So it has to be x squared. Okay. If you subtract, you get 0. You drop down the 0 what? 0x. This is what? This is 0. And that is 0x. Okay. Then you drop down the what? Negative 4. Then you stop there. So this is your remainder. Negative 4 is a remainder. And so the line y is equal to the quotient, which is just x, is your what? The oblique. Oblique what? Asymptote. Oblique asymptote. Okay. So now it says determine whether this crosses the oblique asymptote or not. Okay. So we have to solve what? The function and set it to this x. All right. So when we solve this, we have what? This is going to give us x squared minus 4 is equal to this over 1. So cross multiply. All right. This will give me what? X squared. So you are going to have what? Minus 4 is equal to what? 0. Okay. Negative 4 equal to 0 is impossible. And so what's your conclusion? The equation has no solution. So the graph of the r of x does not intersect the what? The line y is equal to x, which is the oblique asymptote. Okay. Okay. So we have this function r of x is equal to x plus 2, and then what? X minus 2. So we have to find the zeros of the numerator, which are negative 2 and positive 2. Okay, the zeros of the denominator is what? Is 0. So we use this to find what? Divide the x axis into what? 4 intervals like that. Okay, and for each of them, we draw a table and then pick some values and then determine a point on that. Okay, that is where we plot at that point. So we have these intervals, and then for the interval negative infinity to 2, we use what? Negative 3, negative 1, 1 and 3 respectively for the others. And then we evaluate the function r of x at each of them, and we got negative 5 over 3 and positive 3, negative 3, and then 5 over 3 respectively. Okay, and what's the location? If it's negative, so it's below the x-axis, it's above. If it's positive, it is below. If it's positive, it's above. It is below. If it's negative, it's below. And we have these points to plot. Okay, so we're going to put all this together. All right. First, we have the vertical asymptote, which is the line x equal to what? X equal to 0. It's a line not y equal to 0, x equal to 0. It has oblique asymptote, okay, which is the line y is equal to what? X. Now, what are the what? The x-intercepts. Okay, the x-intercepts are what? Negative 2 and then positive 2. Okay. And then the points that we just got in the previous slide, these points, okay, these points, okay, when we plot them, we have the following. Now, we also know that as we are approaching the vertical asymptote from the right, okay, what happens? What do we get? If you're approaching it from the right, it goes to a negative infinity. It goes to what? Negative infinity like this. And if you're approaching it from the right, from the left, it goes to what? Positive what? Infinity. Okay. So we have all this and we can put it together, join these, all right? Okay. We can join these points and come down like that. And this doesn't, okay. We know that it doesn't what? Sorry. It doesn't cross. It doesn't cross the vertical asymptote. Okay. And so it goes through this again, pass through this point and goes to what? Goes to infinity like that. Okay. So if you put in the better one, we have this what beautiful graph. Okay. So it has all the properties we found. You have the line x equal to 0, the oblique asymptote, we have the points and we join them. All right, so this is the graph for the rational function, which was what r of x is equal to x to the, x squared minus 4 over what? Over x. All right, now finally, example we want to look at it is this time, we are given a graph of a rational function. We want to get its what? Its function. You have what? A graph, you want to get what is function. So approaching this, you know the rational function is of the form p of x over what? Q of x. And so we want to determine what is p of x, that is the numerator, and then what is the possible what? Denominator. Okay. Now, before we go on, all right, we know that the vertical asymptotes, they go with what? The denominator. And then where the graph crosses and touches the x-axis goes with what? The what? The numerator. Then notice that if you have a behavior at the vertical asymptote that goes what? Positive, it rises to the right, okay, rises and then falls, that has what? In terms of multiplicity, that's an odd multiplicity. That factor will have an odd multiplicity. And then if it touches, it has an even what? Multiplicity. If it crosses, it has what? An odd what? Multiplicity. Okay, so we're going to use that. And then for this vertical asymptote at what? X equal to 2. See that if you had, when we had something like this, right? It goes like this. It goes like that. Okay, what graph is that? This will have a multiplicity like something like s plus, the denominator is what? Like that, x what? S squared. So it will have a multiplicity of what? An even number. And then the simplest or the least of them will be what? Will be 2 in this case. Okay, so that's the approach. Now, let's first consider the numerator of the rational function, the p of x, and then the lowest terms, and determine the s what? X-intercepts. Well, now according to the graph, the x-intercepts, okay, x-intercepts are, it is what? This is 3. We have for -1 and +3. So you have for x is equal to -1, and then or x is equal to what? 3. So the factors are x plus 1 and then x minus 3. Okay, so we have for p of x, the numerator, possible numerator will be what? The factors multiply will be x plus 1 and the x minus what? 3. Okay, in terms of multiplicity, now look at this. It crosses, so the factor x plus minus 3 will have an odd multiplicity. So it could be 1, it could be 3, it could be 5, and so on. But with the simplest is what? Is 1. So we want to let it have a multiplicity of what? 1. And then where it touches, see that it touches at what? At -1. It will have an even multiplicity. Now, if it's an even multiplicity, then the least of them will be what? Will be 2. Therefore, the possible what numerator, P of s will be what? X plus 1 all squared times x minus what? S minus 3. Okay. So now our job is to find the what? The denominator q of x. All right. So the denominator q of x, what are the factors? Okay, we use the what? The vertical asymptotes. Sorry. Vertical asymptotes. Okay, we know that x is equal to -4, and then x is equal to what? +2. So what are the factors? The factors are x plus what? +4, and what? X minus 2. All right. So now, what are their multiplicities? Okay. You see that at x equal to -4, it falls, and then it rises this way. Okay. So it behaves like what? We have 1 over x3. So it will have a multiplicity of what? Or even 1 over x, a multiplicity of what? 1. So this will have an odd multiplicity. And then the least of them, it will be what? Will be 1. Now x minus 2, look at it at s equal to 2, it falls on both sides. It falls on both sides. So this will have an what? Even multiplicity. Okay, and the least of them is what? Is 2. And therefore the denominator, the q of x, will have the factors will be what? X plus what? 4 times what? 1 multiplicity, and then x minus 2 raised to what? S minus 2 raised to 2 of multiplicity 2. Okay, so if you put this together, then your rational function is equal to what? Is equal to that. Okay, the p of x, and then what? The q of x. And that is it. Okay, so that will be the, now in terms of, we haven't finished yet, because we have what? Y is equal to 1. Okay, what does it mean? If y is equal to 1, okay, it is not the line y is equal to x equal to 0. All right. Otherwise, we say that the degree of the numerator will be 1 more than what? That will be greater than what do you call it? The degree of what? A denominator. Okay. Now, sorry, let me take that back. If the horizontal was the line y is x equal to 0, that is the horizontal axis. Okay, so that means the degree of the numerator is greater than this by 1. I think that's correct. And then if it is equal to 1, okay, that means that they have what? Equal degree. The degree of the numerator and the degree of the denominator will be the same, because they will have what? What do you call it? The leading coefficients, the ratio of the leading coefficient in this case will be s squared times, that will be s cubed, over this one to be what? S cubed, and then plus 1 plus some terms there. Okay, so because of that, that is why the horizontal asymptote, just how it does, it tells me whether they have an equal degree, or the degree of the numerator will be more than the degree of the what? The denominator. So let's go back and see for the q. All right, that's how it's going to be. They have equal degree, and that will be your final what? Final answer for that. Okay, so we know that the degree of the what? The numerator must equal the degree of what? The denominator, and the quotient of leading coefficient must be equal to 1. That is why the y is equal to 1 is what? Is the answer. Now, note that that's the simplest thing, because 1 over 1 is 1. 2 over 2 is also 1. So if I put 2 here, I can put 2 there. But I want to go with the least. Okay. That's what the answer will be that. And that is the end of this section. And I hope it's helpful. We'll do more examples in class. Thank you.